Hey guys, welcome back to the shop. So I've got a little job behind me right here. It belongs to a friend of mine, an acquaintance, and it's a set of wheels off of a car that needs a slight modification, nothing major. All we got to do is drill a hole, but there's a little bit of setup involved. So let me pull you right in here and show you what we are doing. So he's got this set of wheels, and I just remember him saying Lexus. I believe these are going on a Lexus. I'm sure they're an aftermarket, but anyways, what we need to do is the valve stem hole is actually too small. You can see they got two more back there, and I'm already set up on one right there. So I'll take you down and show you what we're doing with our setup. So he brought this valve stem in. I believe they are wanting to install these valve stems into the rims here, or the wheels, and that hole is too small. I measured that being, I believe it was right around 8.3 millimeters. And I think that this valve stem is actually sized at 15 millimeters here, where it's actually supposed to set in the wheel. All right, so somewhere around 390 thousandths is what it's got to be drilled out to. So that's the task at hand. It is on an angle. So I've been using a gauge block here to find the diameter of this counterbore here. Stick the gauge block in there, find the angle, and I'll show you that. I'll show you how I figured that angle. It's nothing super critical, guys. I mean, so this is not anything complicated. It doesn't need to be any more than what I'm doing right here. I set it at 25 degrees. That's what I measured it at. I've got the first one set up here, simply using, I got a couple of 1/2-inch studs in here, and that fits those holes really close. So that'll allow me to take this wheel off, set the next one in, and basically just use our drill bit to fine tune and center up the hole right there. You can use an indicator, but for what we're doing, the drill is going to find it fairly easy. I believe that was a 21/64 drill that fit the hole near perfectly. And we're just using 2 clamps, lightly clamped. We're not distorting the wheel by doing that, but just clamp right there on the lip. And then again, the 2 studs to keep it in the center and indexed properly. All right, so let me show you how I figured this angle out, okay? I've got my set of gauge blocks out. These go from 0.626 up to 0.750 inches. And these are a great way to find a diameter of a hole without having to get in there and try to measure it with other measuring tools. Just simply pull one, start checking the hole, and then keep going to the next one until you get the gauge pin to fit the hole the way you want. So we are at the 0.691 gauge block, and this fits pretty good right here. So our 691 gauge block fits in there nicely. You want it to where you can kind of lightly be able to push it in there and pull it back out without it getting too tight and hung up, and you don't want it loose where it wiggles around either. We got that to where it sits in there nicely. And then some of you guys are probably going to really laugh with this right here, but what I'm doing is I'm using this level app on the iPhone here, and I think it's going to be pretty good for what we're doing. I've got it measured. I call this at 25 degrees, okay? And once I got down here in line with it, sight, and just try to level that out just like you see in the center, that's at 25 degrees. I think that's going to be more than accurate for what we're doing, just drilling a hole here, and that's what we're going to go with. So that's the quick and dirty way that I found the angle of these wheels. And just for reference, we'll show you the level of the table that the wheel is sitting on. You can see that we're 0 degrees that way, and if we come this way, 0 degrees that way. So our reference surface should be good enough for the angle that we're measuring using the phone app right here. 21/64 diameter drill lined up on the hole in the wheel there. And then we're going to be using a 19/32 diameter drill. If I had a 15, I would probably drill it 15 millimeter, but I cannot find my 15 millimeter drill bit. I don't know what happened to it. It got misplaced. This is only a couple thousandths over that. I think it's going to be perfectly suitable for what we're doing here. That valve stem is all rubber where you measure it, and it measures the same diameter as this drill bit here, so I think that's going to work fine. I've deburred the back of the hole there. I think this is going to work. The counterbore is very close at this point, but you can see there, I mean, there's just barely a lip there going up over that diameter that we drilled. So I think it's going to work out just fine. I don't want to shove it in there and get it stuck and then have to try to get it out of there, but I know that that's going to pop in there and do exactly what it needs to do. I think that's going to work pretty good. I think we're going to go ahead and touch this counterbore, because I believe the wall thickness there where this valve stem is going to have to go through is going to be thicker than what's needed to get this lip to kind of pop around this side right there. So I've been using my Stereo groove mic here, and this is a little tricky to get up in here and measure, but the groove mic is actually working really well. Let's see if I can get another measurement on this. I was getting right around 225 thousandths. Yeah. So just using this guy right there, getting in, so around 225, and I think what we're going to make that is make this thickness there 175. So we'll use an 18 millimeter end mill here to go in there and touch that counterbore, clean up that face down there. And then once I clean that up, I'll be able to get a better measurement on there as well. But I think what I would like to do is go ahead and break the corners of this end mill and hone a radius on there so that we don't have a sharp corner down in the bottom of that counterbore. We'll just break the corners here on the pedestal grinder. We'll go to our honing sticks and hone it. I've got it chucked in an 18N Jacobs chuck, and no, this is not the way to properly mount an end mill, but actually I don't have an end mill holder. I needed a little more reach to be able to come down here and touch this counterbore. So I'm hoping that the 18N is going to do the job on holding this like we need to. So let's go for it and see. I do have a depth set. I'm using my quill readout. See if we can just touch the bottom. All right, there's the bottom right there. Actually, a little bit more. All right, so right about there. Zeroing out my quill up here. So what I'll do, I'm going to go ahead and measure that. That was about 30 thousandths, and I'll measure that and see where we're at. This is a tight spot to try to get in here and measure and hold this groove mic, but I've made a cut on it, and I've got the groove mic set to 175. And I'm just showing you that I've got it fitting in there on that land good. So this one's done, and I think we're gonna leave it just right there where it's at. All right, so we got our first wheel done. Hopefully this is gonna be a pretty quick, repetitive job now that we got the initial setup done. Let's see if I can get the wheel out of here. I might have to take this chuck out to get it out. Nope, looks like I got it right there. All right, we'll go grab another one. I had to move XY just a few thou to get the drill to line up cleanly through the hole there. We got her. All these counterbores are different diameters, so we're just going to end up having to clean them up with this end mill. I've got the groove mic set to 175, and I'm just using it sort of as a gauge here to check that land width, and it's going on there. So that's going to work right there. Well, our little plan actually seems to be working pretty well because I'm on my last wheel here, and everything just seems to be working out. The drill, the counterbore. So we'll get this last one right here and this job will be done. I'm sure they'll be happy to get these guys back, and I'll be happy to get my floor space back. Come down and set a 0 on my quill here. Get in there with the groove mic and measure it. All right, number 4 done. Job is ready to go. All right, so our set of 4 wheels are now completed. Our simple little modification, drilling the hole and then adjusting the counterbore so the new valve stems can go in. So these guys are completed, ready to go, and I'm gonna let them know so they can come and pick them up and get them out of here. I think from here, I'm just gonna go ahead and go back down to the do-all and get that set up just the way it's supposed to be. I'll get everything broke down off the table, and we need to go ahead and retram the head and get that ready to go so that that is completed. All right, we're going to try to keep it just shy of the 0 line and see if we can pull the nod up to get it trammed in. We want to snug up the 3 bolts here just so that it's not loose. I've wiped the table off. We'll give it a lick with the precision flat stones here. I can feel a spot down here. That got it. Yep, that feels pretty good now. Just making sure we don't have any high spots from setting vices or other fixtures on the table here, and that we got a nice smooth surface to work with. So we have the table pretty well centered over the knee. We've also got the turret moved back where I usually keep it. So the turret is the position where it's normally run. I'm just going to use the center point here just to kind of find the center of the slot. And then we're going to set up an indicator, and then we'll sweep the table here to adjust our nod tram. This is the indicator setup that I'm going to use to do the tramming here. This is a Starrett number 196 back plunge indicator with a couple of snugs and rods there configured so that you can just put it right there in the spindle and the collet and adjust this where you need to. You don't have to sweep across the entire table, but of course the more reach you have, the more accuracy you're going to see there. But usually if you go, you know, somewhere around 2 to 3 inches on each side to give you about 6 inch, that's really all you need. But this is a great setup for this job. I think it's a perfect indicator for tramming, especially whenever you put the wide button on like this. That allows you to real easily sweep right over the interruptions, you know, the slots here. Looks like I still got it set up from the last time I trimmed here. It's going to sweep across this range right here. So we're going to be reading this point here and this point right there. And I'll get you in closer with my other camera so you guys can see this indicator a little bit nicer, okay? Just get a little preload on at about 5 thousandths or so, and we'll start right there and see where we're at, but it's most likely going to be quite a bit off right there. Yeah, because it's low on the, it's going to be heavy over on this side. You see that we're almost 35 thousandths high over here on this side, or actually the head being low because you're knotted. Another thing to remember whenever you're trying to adjust the nod, get it trammed in, is that you're not actually on the center lines. You know, you're way out here. So whenever you're reading the indicator, you're only reading this as a reference, and you're not worried about how much it's moving. You're only wanting to try to get it equalized whenever you're sweeping back and forth here. So that side's 0 right there, and I know that this side is heavy, so I need to tilt this up. I'm going to go ahead and start moving it now. I'm going to pull the handle here. I'm going to go ahead and take it up to 0 just to see what we did. And we're still low on that side right there. Matter of fact, it's not even touching. So I'm going to bring the table up until it's on 0 there. Bring the knee up. So let's see. We're still, looks like about 12 thousandths out. So we still got to bring it up a little bit more. Go ahead and make another slight adjustment over here. And just keep sweeping it and keep checking it right there. Give you a little closer shot here using the other camera. We've got the back side set to 0. Our front side is still the low side, so we'll go ahead and make an adjustment. So that's what it looks like, about -4. Come back around here at the back. And it looks like we're reading about -2 there. So we're getting very close now. My goal is to try to get this without going past it, and that's oftentimes easier said than done. But I'm gonna go ahead and, so we're gonna start making, you know, like 1/1000th adjustments on it just to try to not slide past it. So we just moved it 1/1000th, so now it's reading +3. I think I told you the wrong reading a second ago. So we're +3 and then -2. Yeah, I was thinking we were a lot closer than that. So tell you what, we'll just bring this side to 0, just like that. Let's see what we're reading back there. Move this handle out of my way. Still a little bit low in the back, high right here. All right, so let's see. Let's just reset that. We're on right about 0. And then looks like about -2.5 back there. Come back around here and let's make an adjustment. So we're still a little bit high on that side. I'm swinging it to the back. Looks like we're lined up right on 0. +2 on this side. Let's see if we can make another fine adjustment. You're at the wrong angle to see this in line, but we're +1 there. We're going to swing it to the back. Let me see where I'm at back there. It looks like I'm right on the 0, so we're very, very close now. Bring it back around here, and I want to try to make sure that I'm in line with the y-axis there. So I'm going to try to split that this time, about 1/2 thousandth right there. Looking good. It still looks like it's on 0 back there. So we're real close right here. This is the part where you really got to kind of take your time, sweep it several times, keep looking at your readings and making sure that something isn't moving, you know, something with the indicator isn't moving, so throw it off 1/2 thou. We're still slightly low in the back. It looks like we're 1/2 thousandths away. because it's easier to see this front side than the back side right there, I'm gonna bring it back around here to this side. And I wanna hopefully move it a 1/2 thousandths. It looks like it moved just a little more than a 1/2 thousandths. But let's see how we did. I think we still have maybe a 1/2 thousandths left to go. About a 1/2 thousandths. So that's minus 1/2 back there, and this one's lined up just past the 0. Let's see if we can do this again. Just barely. Just where I start seeing that needle try to move. So I'm going to 0 this one out this time. That looks good on 0. And that looks on 0 back there. So that looks good. And what I'll do, I'm going to keep making a few sweeps and try to verify my readings of where we're at. And then once I feel like we have it where we need to be, I'm going to go ahead and lock the 3 bolts here, snug those up a little bit tighter, and you got to recheck it. Make sure you always check it a couple times as you tighten this thing up, because it can move on you. All right, guys, so we have our nod zeroed out. I feel very confident on where I've got this indicator reading. Visually, I'm looking back there and I see that lined up on 0. When we bring it around to the front side here, that is lined up on 0. So it may be a few tenths off because we're using a 1/1000th resolution, but this is great right here. This is what you want. So we are going to go ahead and tram it side to side. I'm going to move the table a little bit, but just to tell you, right there, we're almost -1 there. And when you come around here to the other side, right there, we're +1, +1. So our side to side is out a little bit, so we'll go ahead and get that trammed in now. I wanted to tell you though that we did tighten up these bolts, and I rechecked it before that last segment there, so we are good and tight here. So to adjust our swing, we will go ahead and loosen up these 4 bolts right here. And then this is the one that I always end up going the wrong way whenever I'm trying to adjust it. This is the one that you end up kind of chasing your tail on sometimes. Sometimes you can hit it very quickly and get it right where you want it, and other times you don't. So I usually just loosen them up and then just lightly snug them back up just so that it's not completely loose. Need a little bit of resistance on the worm there. So when we cracked it loose, it moved even more. I've got this side zeroed out, and we'll swing it around to this side, and you can see that it's dropped down to that's right around 14.5 thou. I'm going to go ahead and start making an adjustment here with the wrench. And instead of trying to get this one split halfway each time, I like to just go ahead and do a little bit, sweep it. So that's -5, and that's -10 right there. I'm just going to take it a couple more thou. Just be real easy on the pull here. So that is -8. That looks like -6.5. It's really close, and this is where it can get. It doesn't take much, and you go right past your center that you're trying to hit, and then you got to go back the other way. Got to get everything to settle there. So there's a good 0 there. Let's see where we're at. That is not bad right there. That looks like a 1/2 thousandths. Not quite a 1/2 thousandths is where that's at. Let's see if it moved. That is right on 0. And that's looking like about a 1/2 thousandths. Not bad at all. So I just did exactly what I was talking about doing. I tried to give it another adjustment. I ended up going past it. So let me see if I can take it the other way and correct what I just did here. That's about 1 and -1. That looks like a 1/2. Ooh, that looks pretty good right there. I think we might have hit our mark right there. I know sometimes these segments can be kind of long and boring. It's really difficult to kind of show you this kind of stuff, but I'm doing my best here to kind of give you the idea of tramming because I have people ask about these. I thought it'd be a good segment to show, but I believe we have hit our mark. It's lined up on 0. And when we come around to this side, it is lined up on 0 right there. So that is trammed, but let me go ahead and I'm just gonna go ahead and snug these 4 bolts here while you're still set up there. I'm gonna give these guys a nice little pull and I wanna check it and see if it moved. It still looks like it's on 0 there. And we're on 0 right there. So that looks good. I'll pull you in for a tighter shot so you can see that indicator face a little better. All right, we got you on the left side of the table. You can see we're looking good on our 0 there. So let's see if we can move you around here to this side of the table. See if I can get you set up right there. I think you can see it pretty good. Our 0, pretty well lined up. So I'm gonna call our left to right swing trammed. All right guys, well as you know, the wheels are completed and now we have our do-all milling machine trammed in. It is ready to go. I always enjoy being able to share those little segments like that whenever I can. I see the comments. I know that people think that those kinds of segments are helpful, especially for the new folks, people that are new to the channel or new to machining and they're trying to learn this stuff and figure this stuff out, especially all the home shop guys that you know, haven't done this a lot and they're trying to practice. So trying to show my little methods on how I do these things. Maybe it comes across helpful for you. A couple of things to consider that I wanted to mention as well whenever you're tramming in or you're cracking it loose because you need to do an angular machining op over here like I did with the nod. Anytime you crack this thing loose, when you know that it's trammed in, especially if you are sharing machines with other people, but this goes for everybody. If you crack this loose and then you do the job and then you don't tram it back in and you walk away, say like maybe it's the end of the day or you're super busy and you're on these rush jobs and you just got to get something done and you got to run off and work somewhere else, always make a note on the machine if you're going to walk away from it that it is not trammed. Put a big note, tape it down to the table or take a Sharpie and just put on here, not trammed. Do something to indicate to the next guy that the machine is not trammed, that it needs to be trammed, or yourself. You might forget that you walked away. Maybe you brought this back up to 0 and your intentions was to come back and tram it and you forgot and all of a sudden you got another rush job and you run it over here and you got to mill something and then you screw something up because you forgot to tram that in. So leave yourself a note, leave someone else a note. If you've got the vise up here, you know, just write on the very top of the vise with a big Sharpie, not trammed, you know, and let other folks know. I think that's just proper shop etiquette and it's a safe way not to screw up because you forgot to tram it in and you didn't leave yourself a note or for somebody else. So just a little helpful tip I thought I would throw out there for that. And with that, we're all finished up for this video. I do have some other machining. I've got some shafts right there that are going to be coming up for a spray weld, flame spray repair. I've got another lead screw over here off of another lathe that I got to do some repair on. And of course, we have our parts for the American pacemaker that I got to get back on. I will say that we are going to be machining a new lead screw. So I decided I'm going to convert this square thread over to 3/4 5 Acme. So we're going to be machining this guy right here, and we're going to be machining a new nut for this as well. So that's all stuff that's going to be coming up very soon, and I'm looking forward to sharing it with you. All right, hopefully you enjoyed this video. We'll see you on the next one.